I want to discuss something on the theta part solution. Remember, we did our separation of the radial part and the angular part. Our second lesson, we separated the theta part and the phi part of the angular part. So I want to solve this. In this lesson, I want to solve the theta, the phi part, and the theta part. So the first thing I'll do is the solution of the phi part. So the phi part, if you can recall, we separated and we came up with d squared phi over d phi squared plus b phi is equal to 0. But I want to solve this one by having the d operator. That is one thing we use to solve the ODEs. So letting b to be m squared, because I want to have d operator. I can't have that unless I let this b to be a given value which is squared. So having that, the equation becomes d squared over d phi squared plus m squared into phi is equal to 0. Then in terms of the d operator, I have d squared plus m squared into phi is equals to 0. This part here is arbitrary. They are arbitrary. So it means this phi can't be 0. The part which I equate to 0 is this part here because they are arbitrary. So if I equate this one to 0, I'm going to have d squared plus m squared is equal to 0. Then I'm going to have again d squared is equal to negative m squared. Then for me to have d, I'm going to get the square root on both sides. That means I'm going to have an imaginary number. So d is going to give us either plus or minus im, if I get that. So our solution of phi is coming to be a exponential im phi. This one requires the knowledge of the ordinary differential equations. So I assume you have the knowledge of ordinary differential equations. So having this, I'm going to solve this. Then the phi part here will now be equal to a exponential im phi plus b exponential negative im phi, because you can see im is both positive and negative. So I separate the two. But allowing m to take both positive and negative values, I'm going to have phi is equals to a exponential im phi. In that case, m is now a positive and negative values. But also allowing this constant of integration, this a, to be taken by the theta part. Remember, I'm going to solve the theta part. Allowing that to be taken by the theta part, I'm going to have phi is equals to exponential im phi, such that m belongs to an integer. It belongs to an integer where m is equal to 0 plus or minus 1 plus or minus 2 up to a given value, up to an infinity. So for every value of m, it must be a positive one and a negative one. So this is my phi part. Phi is equals to exponential im phi. So this is the solution of the theta, the phi part. This is the solution of the phi part. So I hope that one is okay with you. Unless there is a question, you comment, I'll be able to answer you in my YouTube channel. So let me go to the solution of the theta part. Solution of the theta part. You can recall the previous video we did that the theta part was coming to be 1 over sine theta d theta into sine theta d theta over d theta plus a minus b over sine square theta into theta is equals to 0. So this one, I want to let some things by substitution. I want to come up with the main m. I'm going to make this one to be an associated Legendre differential equation such that I can solve it. So the first thing I do, let a to be L into L plus 1. And L is just the quantum number. M which we introduced for the phi part is also the quantum number. We are going to, after doing this, we are going to talk of those quantum numbers. So let A is equals to L into L plus 1, and X is equals to cos theta. So if you have X to be cos theta, d theta will now be, when you differentiate cos theta with respect to theta, we are going to have negative sine theta. So that means I have dx over d theta is equals to negative sine theta. Also, d theta, because having this, I want to use it to replace d theta which I have here. Cos theta already I have x. d theta also I have to replace. So d theta is the same as d dx dot dx over d theta. This is just a beautiful way of writing this, because if you can see, dx goes with dx, then I remain with d theta. But I want to replace this part in another way. So that means d theta can now be written as dx multiplied by negative sine theta. Why so? Because you can see d theta here is negative sine theta. Then I remain with this part, I multiply by negative sine theta. So I'm going to have d theta, this one, being equals to d dx minus sine negative negative sine theta. If I have this, also we consider this electron, the hydrogen atom, its electron is orbiting around the nucleus in a unit circle. Then the radius is 1. X is in the x direction. Then we can now get the height to be root of 1 minus x squared. From that we know very well that sine theta is equals to opposite over hypotenuse. Theta is this one. Opposite will be root of 1 minus x squared, which are divided by 1. That means sine theta is just root of 1 minus x squared. And also cos theta from this, cos theta is the adjacent of hypotenuse. So I have adjacent x over 1. That means cos theta is x. All this I have will help me reduce this one to an associated Legendre differential equation. So if I substitute this one, I won't substitute because you realize there will be some cancellation which will take place when I don't substitute it. So if I have 1 over sine theta, then I have d theta here to be equals to d dx minus sine dot negative sine theta. So if I just change this one, I'm going to have 1 over sine theta, this one, then d theta will be negative sine theta d dx into sine theta. This also I won't replace. I have sine theta dot d theta, just this part here. I have d theta the same as dot negative sine theta d dx. Then I have this part theta. Then plus, I said let A be L into L plus 1. So I have this A is equals to L into L plus 1. So I have L into L plus 1 minus. Also, B we must give it some given value squared. And this one must be a quantum number. So I say that would be let M squared. So I'm going to have L into L plus 1 minus M squared over sine squared theta. Remember sine theta is root of 1 minus x squared. If I square this, I'm going to remain with 1 minus x squared. The whole of this one is operating on theta. So this one cancels this. I remain with negative d dx. Then inside here I'm going to have negative sine theta multiplied by sine theta is sine theta to sine square theta. Then negative, I bring this negative inside, so that it will now be positive. So inside here I'm going to have sine square theta d theta over dx plus L into L plus 1 minus m squared over 1 minus x squared operating on theta. So the next thing I'm going to do is rearranging that. I'm going to have d dx into 1 minus x squared. Remember, sine squared x is the same as 1 minus x squared. D theta over dx plus L into L plus 1 minus m squared over 1 minus x squared into theta being equals to 0. This is an associated Legendre differential equation whose solution is given as PLMX. So PLMX, that means the theta part will now be, remember we said that the constant of integration will be taken by the theta part. So I introduce that constant of integration. So the theta part is now equals to C PLMX cos theta. Remember this one is x, but what is our x? Is cos theta. So I have now theta is equals to C PLMX cos theta, where this m is a quantum number, L is also the quantum number. I'll mention the two quantum numbers. Let's just proceed with this. We'll reach a point where I want to mention those two quantum numbers. So this one is my theta part. For a given value of L, there are conditions for this one to hold. For a given value of L, there must be a positive or negative value of M. So M will be a positive 0, positive plus or minus 1, plus or minus 2, until we reach a given value of M, of L, which also be plus or minus. So M will be taking 0, plus or minus 1, plus or minus 2, until we reach plus or minus L value we are given. So remember, we want to have now the spherical harmonics. So the spherical harmonics is y. Remember we let y to be as a function of theta and phi. That is what we call as the spherical harmonics. So the spherical harmonics is now given as C PLMX cos theta exponential Im phi. Remember theta was, phi was this, and theta is this one. Then constant of integration is that. So the spherical harmonics is given as this: C PLMX cos theta exponential Im theta. So this is what I have as my theta pattern there. I have the spherical harmonics. So wait for the solution of the radial part. I hope the lesson was enjoyable, and subscribe to my YouTube channel. I hope you will have more enjoyable videos dealing with quantum mechanics, majorly the hydrogen atom. Welcome.